All right, good morning, everyone. Thank you so much for joining us. My name is Katie Grillo. I'm the GIS Web Technology Specialist at the City of Cambridge, Massachusetts, and I'm also your NEARC Board President. And I'm here this morning to welcome you to day 2 of our fall NEARC conference. And yesterday was incredible. Our first day of the conference was packed full of amazing content. We had a keynote speaker from Esri, Lauren Bennett, and her colleague Alberto Nito, and they had a fantastic talk about spatial statistics. From there, we moved on to our concurrent user sessions, and these were all of our user presentations from our community, as well as some technical presentations from our friends at Esri. We did have our business meeting yesterday. Thank you so much for those of you that attended. We're excited to announce that Brittany Hoffnagel was voted back into the board for another term. And after that, we had our vendor and poster social. And a huge thank you again to all of our poster presenters. So we had brief lightning talks from each one of our poster submissions yesterday. And now it's your turn, folks, from the crowd. We need you to please go and vote for your favorite poster. So we do have a People's Choice Award. And voting will end today at noon. So you can follow this QR code or visit the poster section in Whova to get the link to join the voting. And again, that'll end at noon today. And then I ask that you please come join us at our Mappy Hour event this evening at 7 p.m. where we will announce the winners from our poster event. So today we are here, we are at the Welcome and Keynote. Very excited to have Jennifer and Aaron with us from the Woodwell Climate Research Center. And then we also have a special guest, Alan Carroll, here that is going to introduce our keynote. So we'll get to that in just a moment. But first, I want to say we do have another day that is packed full of concurrent sessions. Yesterday, we had two concurrent session blocks, and today we have 3. So there's a lot going on, all these user presentations, Esri presentations, and then this evening is the Mappy Hour, which I'll talk about in a second. And we will not have a welcome address like this tomorrow morning. So I also just want to give a shout out to our sessions that are happening tomorrow. So that is an opportunity for you to do some deep dive workshops. So we'll have Esri follow along workshops, as well as some workshops from our user community. I want to mention that we heard a lot of feedback yesterday of folks who were struggling to kind of navigate between those concurrent sessions that were happening. So big shout out to Emily Wilson, who threw together this session grid for us yesterday. And we posted this up to the Whova site. So if you go to the community section, there's a new page called NEARC Current Session Grid. And there's a little bit of chat going on in here, but if you scroll up, then you'll see this is where we posted images of the concurrent session grid so that you can kind of see what's going on at the same time and use this to try to help you make a decision on to which presentation you want to attend. There's a link in here too that will take you out to the full schedule. So this shows you all of the different concurrent sessions all at once. So again, I just want to say a big thank you to Emily Wilson for putting that together, and thank you to all of you for submitting your feedback. You know, we're still new to this virtual hosting thing. So if you do have comments or if things are frustrating you, then let us know, and maybe we can come up with a solution like we did with this one. So tonight we have our NEARC Halloween Mappy Party, and this is kind of like our wrap-up session for the conference. As I mentioned, we do have our workshops tomorrow, but this is our last social event of the week. So we will be having hopefully having a lot of fun. We did say that costumes and festive attire are not required, but highly encouraged. So come join your colleagues, and we're going to have a lot of different like Halloween-y, mappy conversations and themes and games and that kind of stuff. So hopefully you'll come join us. And as I mentioned here, we'll have announcements for our poster winner, and the board seat has already been decided. So tonight our announcements will just be those poster winners. We do still have the NEARC Let's Move is going on. So this is an opportunity for you to get out there and walk, run, bike, or use the other category to rack up some miles over the week. We have a quick capture app that was created by Mike Olkin. Huge thanks to Mike. And so you can use this QR code to access the quick capture app. And then all of our results are in a results dashboard. So I've got some stats along the bottom here. This is from, I think I captured this at like 7 p.m. last night. So we've got a lot of action so far. We've covered 86.28 miles, and I'd like to challenge us to get up to 200. I think we can do that easily. So this event is going to go until end of day on Sunday. So the conference will end tomorrow, but then you'll have the whole weekend to get out there and rack up some miles. And we do have prizes for the individual that walk the highest achiever, so to speak, from each one of these different categories. So I encourage you to get involved in that. We also have our conference connecting within Whova, and there's, just as I pointed out a moment ago with the NEARC session grid, under our community section, there's a ton of different chats going on here about all kinds of different topics and presentation ideas, that kind of thing. And so far up to this point, we have had over 1,000 messages, and you can see these are just some stats from behind the scenes of how many folks have downloaded the app, how many photos have been posted, that kind of thing. And this is our current leaderboard. Again, I think this was like 7 p.m. last night. And our top 3 individuals are going to also be receiving a prize. So the more you interact within Whova, the more points you earn, and then you can kind of climb the ladder there. So right now, congrats to Nicholas Burns. We'll see if Nicholas can hold that #1 seat, or if we've got Nate and Tom and Erica. Yeah, so a lot of people in the running right now, so keep it up. I want to say again a huge thank you to everyone who helped put this event together. As I said yesterday, we are a nonprofit, volunteer-led organization, and each one of the names that you see on this list here, they have their own full-time jobs, they have their own full-time lives, and yet they take the time to volunteer and help put together these events for you. So a huge shout out and thank you to our host committee, Shane and the other folks who helped put together Educators Day. As always, our friends at Esri, and this list, there's more people at Esri that have been helping out behind the scenes, but this is kind of our main NEARC Esri team. And then I need to give another shout out to Leslie and her group at Delaney. They have really, really stepped up over the last year and helped us to navigate this brand new world of virtual conferences, and have really helped a lot behind the scenes to make this a seamless and enjoyable event for all of you. Finally, I just need to thank our sponsors. Without them, this really would not be possible. So we had our bingo event last night to try to highlight some of our sponsors and say some fun facts about the people that work at these different companies. So I encourage you to please go into Whova and check out the sponsors section. From there, you can visit each one of these different booths, and they do have a little chat section in there as well. So I encourage you, if you have questions, you want to learn more, or even if you just want to go and say hi, I encourage you to do that as well, please. So thank you again so much to our sponsors, and thank you to all of you for helping to support our sponsors. All right, that's enough from me. I now am going to move over to our keynote address for today. So we have a special guest, Alan Carroll, who is joining us, and he's actually going to introduce our speakers. But first, I just want to say a couple words about Alan. So Alan, he joined Esri back in 2010, and prior to that, he was at National Geographic for 27 years. And after he arrived at Esri, he founded the Esri Story Map team. And over the last decade, Alan just strikes me as somebody who is very passionate and curious, and he really prides himself in finding amazing examples of how people all around the world are using these story map tools. And I had the privilege of collaborating with Alan on a presentation a few years ago at the UC, and he is just a joy to work with. And when NEARC needed a keynote speaker for today, I immediately thought of Alan as somebody that I could reach out to as a friend and a colleague. And he came through and suggested Jennifer and Aaron and their talk. And so we are so excited to have Alan here to give us a little quick highlight on some things going on with the Story Maps team, and then he will introduce our keynote speakers. So Alan, thank you so much for being here. I'll pass it over to you.
Great, thanks Katie, and thanks for the kind words. As you might have noticed, I'm dealing with an unexpected challenge. You never know with these remote presentations, but I've got sunlight streaming in from a neighbor's window. I shouldn't complain about bright sunlight, but I think I can manage, and I'll probably sort of fade into the shadows as we go. At any rate, a couple of weeks, 2-3 weeks ago, I joined a bunch of Esri colleagues to meet with several people from the Woodwell Climate Research Center, and was just blown away by this beautiful hub site that they created and a suite of story maps that they and others, including I think students at the Harvard Kennedy School had created. And then by a serendipitous coincidence, the very next day, I get an email from Katie saying, hey, we're looking for a keynote. And of course, my first thought was, well, these Woodwell people would probably really impress the NEARC group. So thrilled that has happened. I'm going to share my screen real quick before I introduce Jennifer and Aaron, because Katie's agreed to give me the opportunity to update you a little bit on what's up with Story Maps. So I'm going to highlight a few recent developments and then describe very quickly a couple of things that are coming up soon. So first, as of a few months ago, we have a new timeline block in Story Maps. By the way, I'm not introducing Story Maps because I'm happily assuming that all of you know what Story Maps are and kind of don't need the sort of overview. But at any rate, not a very happy topic here, but as you can see, the timeline function is a great way to show a sequence of events and not necessarily dates. It can be sort of, they can be steps in a recipe, etc. So that's an exciting new development. Also, if you've got time-enabled web maps and you add them into a story map, there's a new widget that automatically adds a play pause function to your time-enabled map. So previously you had to embed another app to make that happen. So that's I think that's kind of cool. The most exciting stuff for me has been happening with collections. I don't know if you've used collections, but we started out by providing a way to aggregate a number of story maps into a single collection page. And we've made those more and more versatile in several ways. So this is kind of the standard look at a collection page. This is kind of the default view, but we've added the ability to incorporate the themes that you create in our theme builder into collections. And also we have different layouts. So as you can see, this is a different format that kind of features an introductory story and has of course, custom fonts and background colors, etc. Here's another layout. This one I just put together a few days ago, realizing that there are lots of cool campus tours around the country and world, and thought it might be a nice way to feature those. So collections are an exciting thing that I think can replace what people are sometimes still using among our classic apps called Map Series, but this we feel is more powerful and versatile. A few other things that we've added recently is you can now link to points within stories. You can't, previously you could only link to the story itself, but if you have a story with headers or subheaders within it, you can create links to those. You can also make data-driven map tours of up to 200 points. So this is creating essentially a feature service that can display a bunch of points that people can explore. If you want to keep track of, I'm going to back up to collections. I forgot kind of the punchline of collections, which is now within collection pages, you can not only include story maps and Esri apps, but you can essentially embed anything with a URL. So this provides all sorts of powerful new stuff. One of our education specialists in the UK created this aggregation of content about the recent lava flows in La Palma, including web scenes and Google Slides, etc. So that makes collections really powerful. If you want to keep track of what's new on ArcGIS Story Maps, just go to the ArcGIS blog. Every month, Owen Evans, who's a great writer and communicator and way more technically adept than I, summarizes these all the new features. So please keep track of what we're up to via his blog. Just a quick overview about what's coming, and this is just the kind of the tip of the iceberg, but some of the stuff I'm particularly excited about. Around the end of the year, we're going to launch a curated gallery of ArcGIS story maps. So a lot of you are probably familiar with the gallery that featured our classic stories. Finally, and it's taken us longer than we had hoped, but at any rate, we'll soon have a beautiful gallery of dozens to hundreds of ArcGIS story maps that you can use for inspiration. We're also going to replace our current text editor within the builder, so you'll have greater flexibility with text formats, etc. We're going to incorporate some simple image editing tools, so you can do things like, I think, adjust colors and crop images, etc. And we're also going to introduce 3D express maps and 3D tours using web scenes. So that I'm going to stop my share. Please, of course, let us know if we're missing features that you feel we should be considering. We really value your input, so do let us know. But on to the main event here. I'm really pleased to introduce Erin and Jennifer. Erin McDonald is a research assistant in the Arctic program at Woodwell Climate Research Center. She received her bachelor's degree from the University of Waterloo in Ontario, where she was first exposed to the complex systems in the Arctic. This led her to get a master's degree at the University of Alberta, where she was able to travel to the Northwest Territories, which deepened her connection to the Arctic. She's currently working remotely from Edmonton, Alberta. So as you know, that means she's up pretty early this morning. Thank you, Erin. And she indulges her passion for both fieldwork and science communication by splitting her time at Woodwell between leading the development of the hub site that she'll show you shortly and assisting with fieldwork duties. Outside of science, she enjoys hiking, snowboarding, pottery, poetry, and her dog Raz, presumably not simultaneously. Dr. Jennifer Watts is a scientist at Woodwell and is an affiliate professor of remote sensing at Montana State University. Her PhD in systems ecology is from the University of Montana. Jennifer's work focuses on using remote sensing and geospatial data to understand how ecosystems are changing across regions spanning from the Arctic to the mid-latitudes. Dr. Watts is currently working remotely from Bozeman, and when not in the field or at her computer, she enjoys active time outside with her partner and her furry children, in other words, her dogs. So thanks so much, and take it away.
Thanks, Alan, for that great introduction. So let me go ahead and share my screen. Okay, so thank you, everyone. Good morning. Today, Erin and I will be sharing with you how our Arctic Boreal group at Woodwell Climate is using Esri products to visualize and convey data in a manner that is more approachable for a broader audience, and how we're using data-driven storytelling, like Alan described, to share the important message of climate change and how this is impacting the Arctic and in turn the globe. But first, we're going to start with a land acknowledgement. Woodwell Climate Research Center in Falmouth, Massachusetts, so on the Cape, is located on the traditional and sacred land of the Wampanoag people who still occupy this land, and whose history, land, and traditional ways of life continue to influence this vibrant community. I'm calling in from Bozeman, Montana, which is the ancestral home for many indigenous peoples, including the Crow, Nez Perce, Lakota, Blackfeet, Salish, Shoshone, and Northern Cheyenne.
Thanks, Jenny. I'm calling in from Edmonton, Alberta, Canada, which is located on Treaty 6 territory and is the traditional land of the Papachays and has been a meeting place for Cree, Blackfoot, Métis, Iroquois, Dene, Inuit, and many Indigenous peoples.
And we invite you to think about where you are presently and the people who came before us. So to begin this presentation, I'm going to have us visualize the Arctic. What comes to mind when you think of the Arctic? So this map shows the Arctic region I'll be discussing today. The Arctic is a very large place. And here we're loosely referring to the Arctic as the permafrost or frozen ground region, spanning Alaska, Canada, Northern Scandinavia, and Russia. And you'll notice that this region extends well outside of the Arctic Circle. It's 66-degree latitude. We see the Arctic Circle in the dotted line. And in fact, the permafrost landscapes cover 23 million square kilometers. That's approximately 9 million square miles. And this is almost a quarter of the total land area in the Northern Hemisphere. When we're presenting to the general public, we often find that people are surprised to learn that the Arctic, even in the very far north, is not a frozen wasteland. In fact, it's quite the opposite. In the colder, more northern regions and mountainous areas, we have treeless tundra ecosystems. So these are the areas in this map shown in tan. And these tundra regions can be incredibly lush during the very short 2 to 3 month growing season. And then further south in the slightly warmer regions shown in green, we have the boreal zone where we find trees. Across both tundra and boreal, there are large expanses of wetlands and surface water, including lakes and rivers like we see in the photo, and that they provide really important habitat for migrating birds. The Arctic region also provides critical habitat for large and small mammals, including caribou, moose, Dall sheep, the iconic polar bear, these adorable muskox, this little guy here, and then wolves, just to name a few. And of course, the Arctic is also home to people. A recent paper reported that there's approximately 1,100 settlements across the region and a total population of 5 million. In this map, the location and relative population size of Arctic settlements is indicated by the size of the circles. So we see that people are just about everywhere in the Arctic. In addition to recognizing the locations and size of human settlements in the Arctic region, importantly, we also recognize that these lands are home to many indigenous peoples who have lived here for thousands and thousands of years. And this really reminds us of the great cultural diversity, in addition to biological diversity, that exists within this large area. But unfortunately, the Arctic, this large, diverse, and beautiful region, is under threat from climate change. The Arctic is warming more rapidly than elsewhere on Earth. And the red on this map indicates that just about the entire Arctic region is warming, except for a very small portion of Canada. You see this in the blue. So the darker the red here, the more extreme the warming. And the Arctic is warming more and more rapidly each year. This graph indicates departures from the 1959 to 2019 average. Red indicates warming, which continues to rise. And here we're only showing warming through 2019, but we know that in 2020 and 2021, temperatures have continued to rise off the charts. And our climate models indicate that rampant Arctic warming will continue through the next century, especially without global emissions reductions and climate mitigation efforts. These globes indicate projected climate warming through 2060 into the next century. The topography, along with the dark red coloring, again indicates that warming will be most pronounced in the Arctic region, especially in Alaska, Canada, and portions of Siberia. So you may be asking, well, isn't warming of a very cold place a good thing? The answer is, in many cases, it's not. Arctic warming is rapidly melting sea ice and with many consequences, including the loss of habitat for those polar bears. Warming temperatures are also melting ice sheets, including those in Greenland, contributing to rising sea levels. And when we think about the human component, we should be aware that many residents in the Arctic rely on frozen ground conditions for travel across land. Unfrozen ground is often very wet and dangerous to cross, as is unfrozen water. So I wanted to share this picture with you from Alaska. This is from the past winter, and this really emphasizes the importance of frozen ground for a lot of Arctic residents. Here, this doctor, you see the doctor by the plane. The doctor's carrying COVID vaccines that are needed for a rural village. So instead of just going down to our local pharmacy, because some of these villages are so remote, they need the vaccines transported to the village. And here the doctor gets in the plane, lands at the closest landing spot, carries the vaccines, and they're about to pack up the vaccines on the snow machine and sled. And then the sled is going to travel over snow to the village. And so the person driving the sled, as well as the villagers, are really relying on those consistently frozen, stable ground conditions to reach a village safely. And so if you think in the future, as the Arctic warms, travel across ground is going to become more and more hazardous. Warming temperatures are also very detrimental to cold adapted plants who are increasingly experiencing severe drought stress in summer and who are losing productive blankets of snow in winter. And it's really making them susceptible to die off because of temperature swings. Arctic warming is also a threat because of thawing permafrost. Remember earlier I mentioned that the Arctic holds a large amount of permafrost, and this is ground that is frozen for at least 2 consecutive years. Well, these permafrost soils happen to hold a very large amount of organic carbon, twice the amount of carbon currently contained in the atmosphere. So this picture shows my colleague Luda standing next to exposed permafrost soils in northern Siberia. And this vast wall was formed when a large chunk of land thawed and collapsed because of climate warming. If you notice the dark colors of the earth, these are now exposed, very rich organic soils. Just think about your compost pile at home. If it gets warm and wet, it starts decomposing rapidly. And the glistening that you see up in the corner, this is from ice melting and water seeping through the soil. And these changes are happening very quickly across the Arctic. So as permafrost thaws, the once cold protected organic carbon becomes very easy food for microbes. And the byproduct of this is production of very potent greenhouse gases, carbon dioxide and methane. More greenhouse gases in the atmosphere leads to amplified warming across the planet. And this is very bad for you and I and the 7.7 billion people on Earth. Even though climate-related risk is recognized as a national threat by the US and other countries, a majority of the global public and policymakers remain unaware of how quickly the Arctic is changing and the great risk posed by thawing permafrost soils. So to raise awareness and to really sound that alarm, my group at Woodwell Climate partnered with Esri and Harvard's Belfer Center to form a team of scientists, cartographers, and policy experts. And I want to quickly introduce you to our project team at Woodwell. Starting in the upper left is Dr. Sue Natali. She's our project lead, followed by Dr. Brendan Rogers and myself. And then we have Erin, who you've met and is part of this presentation, Rachel Treharn, Anna Virkola, Scott Zolkos, Tiffany Winholtz, Stefano Potter, Darcy Peterson, Peter, and these are our primary science staff on the project. And last but not least, I want to introduce to you over in the corner here, Greg Fisk and Carl Churchill. And these are very talented cartographers and GIS specialists at Woodwell. You can learn more about our group at woodwellclimate.org. For the Harvard side, we're working very closely with Dr. John Holdren, Henry Lee, Joel Clement, Paula Yoidotev, and Fran Ulmer. And I invite you to check out the very important work that they're doing with Arctic policy through the belfercenter.org Arctic Initiative. With our Esri collaboration, we're working very closely with Dr. Don Wright, Ben Suskalski, Adam Jenkins, Charlie Fry, Kevin Butler, Riley Peak, and Alan Carroll, to name a few. So our team's first objective is to use geospatial information to document Arctic change. And this includes a wealth of data from satellites, in addition to point-based ground observations across the Arctic region. One example of how we're trying to tie together these multiple streams of information is through an ecoregion hotspot analysis. So the map here shows our results from a GI star analysis that we ran through Esri ArcGIS Online. And our inputs are various geospatial layers derived from satellite imagery that serve as primary ecosystem indicators. And these indicators tell us about how various ecosystem states have changed over time. So examples of these include thermal states, and this could be soil and air temperature or surface frozen or thawed status. These also include water indicators, for example, soil moisture, surface water, and flooding. And we're also looking at vegetation indicators. For example, have there been trends of vegetation greening or browning, indicating vegetation die-off? For this project, we converted terabytes of imagery into cloud-optimized geotips so they can be quickly and efficiently processed in a cloud computing environment. For this particular project, it's supported by Microsoft AI for Earth using Azure resources. So our initial results from the hotspot analysis shown here indicates that ecosystems are changing across the Arctic. And this is happening most severely, as indicated by the darker red colors in Alaska, so up in this region, in Siberia, and parts of Scandinavia. And this tells us that in these areas, severe warming, severe water conditions, be it too little water during summer drought or too much water in times of flooding, and dying vegetation, it really indicates that these areas may be experiencing ecological tipping points and ecological instability. And one of our next steps using GIS is going to be identifying how these instabilities may be directly impacting human populations and infrastructure. Our second objective is to install new on-the-ground monitoring systems to better understand the drivers of environmental change and to quantify the increases in greenhouse gas emissions coming out of the permafrost landscape. The monitoring stations that we'll be installing are similar to those shown in this picture. This is from our Yukon-Kuskokwim Delta in Alaska station. This houses a weather monitoring station and gas analyzers that track gases entering and exiting the ecosystem. So these are really specialized technologies, very advanced, and we're hoping to deploy them across the Arctic region. This is really important, as seen in this map. The black dots show the sparse locations of existing monitoring stations. So these are the stations that are already up and operating, and there's a lot of spatial gaps. In a lot of the Arctic, we don't have information about what is changing on the ground. And so the yellow dots are the proposed locations of our new monitoring stations that we'll start to install next year. And this is in collaboration with multiple agencies and other organizations across the globe. Our third and perhaps most important objective is to share Arctic data and stories of Arctic change in an online format that is easily accessible and relatable to a wider audience. And we're doing this through our new online Esri Hub, Unstable Ground. And now Erin is going to walk us through the Hub site and showcase some of the features found in unstableground.org.
Thanks, Jenny. Let me just pull up my screen here. Okay, so thanks for that great introduction, Jenny. So as Jenny mentioned, we have an Arctic carbon monitoring and prediction system team at the Woodwell Climate Research Center, which has a few different components. So with this big project, there's a few umbrella items. So we do field research to better understand the processes driving emissions from permafrost thaw and wildfire, as well as monitoring of key variables. We also have remote sensing, which scales up kind of field-based observations to the full Arctic region. We do modeling to evaluate the implications of Arctic permafrost emissions for global climate policy. And of course, communication, which is what I'm so excited to talk about with you today. And so this includes development of a high-powered and interactive web visualization platform to communicate Arctic change to the public, policymakers, and Arctic residents. So Woodwell Climate Research Center established a partnership with Esri, and at our first initial meeting, we just kind of expressed our needs of wanting to share information, maps, data, and more, but we weren't really sure exactly what would be the best avenue, and they recommended that we explore using a hub site. So a hub site is a platform in ArcGIS Online, which means that it's linked to all the maps, apps, story maps, and everything that's stored on ArcGIS Online. And in addition to all of the content available with your account or organization, there are also tons of public resources that are publicly available for people to use. So a hub can be as simple or as complex as you like, and you can actually create as many hubs as you want. So in developing our site, we wanted to reach a number of different audiences with different needs. So we wanted to communicate to the public to raise awareness about the Arctic issues and kind of share the science beyond scientific publications. So this would require us to use simple language and present data and information in kind of intuitive formats that are easy to understand. We also wanted to communicate to policymakers so that they understand how crucial the Arctic is and why we need emissions incorporated into carbon budgets. So this would require kind of placing things in a policy relevant framework, such as how potential changes may affect climate targets or legislation. And we also wanted to share our data with Arctic residents and help to share their stories about why the Arctic is so important to them. So this would require open access data and collaborating with local knowledge holders and experts. And finally, we wanted to share with other scientists, geospatial analysts, and regional land managers. And so these audiences would require more in-depth information about the data and the science, and the need to kind of scale between the circumpolar region and then scale very down to regional specific targeted trends and data. So once we identified our key priorities to include, we started to think about design and how we wanted to kind of align the site with our branding. So this project is just one project under the Woodwell Climate Research Center. So this is kind of our parent site, and it shows kind of the overall design of that site with a center panel, the larger font text, but not tons of text, and then really highlighting the photos and the images on that site. So if creating a hub seems intimidating, then I want to reassure you that about a year ago, I had not really heard of the hub technology. And I wanted to share this image of early brainstorming. So when we were thinking about the overall layout, we kind of played around with different options using placeholders. So this is a very early version of our idea. And we knew we wanted a few different pages with some different themes. And we wanted images, data, apps, and story maps, but it was all very theoretical at this point. And so about a year later, I'm excited to share with you what it looks like now. And I think it's an immense improvement from that early version that you just saw. So starting at our homepage, one of my favorite features on the hub is this ability to make a photo a fixed background, which creates this immersive scroll. And here we're just providing some background information. So there is some overlap between the wonderful introduction that Jenny gave us all. So just highlighting that the Arctic is warming. And we have this really awesome data visualization by Greg Fisk showing the projected warming as elevation. And then we have some text with hyperlinks to a few of our different pages and just some more information about what the site's about. Another immersive photo to divide the content. And then we provide some statistics. So these actually started out as statistics cards, but we're still finalizing our data sets. So we actually are just using the text for this, but we distinguished it by different font sizes and colors. And using the text, we were able to add hyperlinks. So this is linking out to another page that describes a bit more background information about what a temperature anomaly is. So thinking about kind of our public audience who might not be familiar with the term, they can click and find out more. Or we have our sources for the scientists or geospatial analysts who want to learn more. And again, just highlighting how rapidly the Arctic is warming and also how much organic carbon is stored in the Arctic. And then scrolling down a little bit, we have this really cool interactive map that Greg Fisk put together. So this is using the latest Esri JavaScript API. And we have a few key variables. So the mean temperature, the temperature trend, and then we have NDVI. So this is the mean normalized difference vegetation index, which kind of shows the greening or browning of the region. And then the trend would show kind of the net effect of what's been happening over the last few decades, if there's been net greening or net browning in different regions. And then we also show the precipitation, so where areas have been getting more wet or more dry. And then we have a few of our story maps highlighted here on the homepage, and Jenny will walk you through those in a bit more detail later. And then I'll just take you to our About page. So this is just information about who we are, scientists with a message, trying to convey our information. And I think Jenny did a great job of introducing the team members, but I just wanted to really emphasize that the hub was a massive team effort. So we have kind of a range of different topics that we're able to provide information about, and it's really because of the breadth of knowledge that these experts have. So yeah, it's been a great effort by many people. And we have these different theme pages. So the first one I'll walk you through is climate. And between these theme pages, we wanted to keep kind of a similar layout. So as you start at the page, it's a little bit more background information. And then as you move further down the page, it gets more complex with kind of the data. And then at the end, you can really dive into a topic with the story map. So this climate page is all about how the climate in the Arctic is very unique. So you can have 24 hours of sunlight in the summer and then basically no sun for all of winter. But of course, how these conditions are also changing really rapidly. The warming is fundamentally changing the ground. And another map that was shown earlier, coupled with this chart to kind of convey how the temperatures have been increasing in recent years very rapidly. And we divide the content with another immersive photo. We have some statistics on the increase in extremely warm days. So there's almost a week longer of extremely warm days than there was in 1981 to 2010. And then we also see that most of the Arctic region, so 93% of the region, has had the number of days that the ground is frozen been decreasing, which is basically analogous to the thawing that we know is happening in this region. And then we also have our story map there. You could explore and dive into a topic. And the next page I'll take you through is the ecosystem. So this is really showing that the Arctic is a living landscape. It's not just snow and ice. There are plants and even little wildflowers. They're small and adorable, but these habitats are changing. So this is a map showing the NDVI that I mentioned, which is kind of the greening and browning, which can kind of represent changes in vegetation or drying out. And we have a scientist doing field work here with an immersive photo divide. And then some statistics. I'm really struggling with that word today. And the next page I'll walk you through is fire. So even the Arctic can burn, which is pretty wild, and sort of a unique phenomenon in the Arctic because there's so much organic carbon in the soil that even the soils can burn, as opposed to just kind of the trees is what we're used to with kind of wildfires. So burned area map, some more photos for the background, and kind of explaining the change in albedo from the black soot. We have an immersive photo divide, and then statistics for the increase in burn area and the associated carbon dioxide emissions from fires. And something cool on this page is we have this interactive chart that Carl Churchill put together. So you can explore the burned area from different circumpolar regions in recent years. And it's really fun to click around. So I would encourage you to go check it out. And this is input with an iframe. And then we have another story map relevant. Our permafrost page, which is all about permafrost. So this is ground that is kind of permanently frozen. And the Arctic really relies on this stable ground, as Jenny mentioned, and a really vast region. And the ice in the permafrost can have really big implications for its collapse. So permafrost that has high ice content, like this jar and kind of the middle one, when they start to warm, they can actually collapse because that ice just turns into water, whereas ground with lower ice content doesn't collapse quite as rapidly. So this can have really big implications for kind of this slumping effect that you see where the permafrost can just completely give way and mobilize a whole bunch of soil. And then we have a photo of scientists taking a permafrost core, some more statistics, just conveying how large the area is. So and the amount of thawing that might take place with active layer thickening, and a story map delving into the permafrost. Our carbon page, so carbon is integral to life on Earth, of course, and it's also been accumulating in northern soil for thousands of years. And this is partly what makes the Arctic boreal region so sensitive to climate change. So it's sort of been acting as a carbon sink, so storing lots of carbon as it's been accumulating due to low composition in those low temperatures. But as we're seeing more warming, some of that organic carbon may be liberated and released into the atmosphere as carbon dioxide or methane. And this may lead to it becoming more of a source than a sink. And some more statistics kind of highlighting that there's lots of organic carbon, both above ground and below ground. And then we have some story maps here. So we have our story maps collection page, which has been a fan favorite. So these are a few of the story maps that both our team and students from the Harvard Kennedy School have put together. So I wanted to walk you through this example, mapping Arctic terrestrial carbon flux sampling sites. This is by Tiffany Windholes from our group, and she puts together really fantastic story maps. So I'm just going to kind of breeze through this, but just to give you a little taste of what you can find on our story maps stories page. So exploring the tundra and boreal biomes, and then we kind of explain the different ways to measure this carbon flux. So either using these towers, which Jenny showed, or there's also these little chambers for more of an isolated measurement. And then we have some really cool maps that kind of scroll through the current distribution of sites. So this one shows by the boreal versus tundra. And then Tiffany also put together based on the climate mean temperature, as well as mean precipitation, and then how those sites are dispersed kind of based on temperature and precipitation together. And then also showing the distribution of sites based on the soil organic carbon and the different permafrost zones, which can range from continuous to sporadic, and based on estimated carbon stocks. And then highlighting, as Jenny mentioned, kind of some of the gaps in our sampling sites across the circumpolar region. So a really cool story map. And one other thing that I wanted to share with you. So this isn't on the hub yet, but we're hoping to add it very soon. And this app was developed in large part by Bob and John at the Research and Development with Esri. And so this is an app just to show the air temperature trends and the kind of frozen ground, the number of days with frozen ground. So that would be analogous to the thawing. And what you can do is you can actually input a location. So I can input New Haven here. And we can see how the trends in recent years compare to the Arctic boreal zone. So there's our little dot on the map. And we can see that the air temperature is much warmer in New Haven, and we can compare the trend difference. So you can see the Arctic has been warming, and you can span across 20, 30, 40, 50, and even up to 60 years to see how those temperature trends have been changing. And scrolling over to our frozen ground tab, so then the map will update to reflect that data. So there's no frozen ground in New Haven, which might not surprise any of you here. So I can input Edmonton, which actually does have some frozen ground, thanks to the Canadian climate. And we can see the difference between the number of days with frozen ground as compared to the Arctic boreal region, and kind of explore more that way. So our next steps for the hub, we're looking to expand our community component, and we have a few more ideas for different content for kind of targeting policymakers, teachers, and we want to enhance our data sharing. So right now it's mostly just kind of apps and maps, but once we finalize our data sets, we want to have those publicly available. And I encourage you to go and check it out yourself. It's a lot of fun to click around and explore. And we have a vast array of story maps on many different topics. We also have a Twitter and Instagram account. So this is Woodwell Arctic, and we'll be posting about our updates and new content there, so you can follow along. And you can also reach out to myself. My email is there, emcdonald@woodwellclimate.org, or we have a hub web email, which you can find on the contact information on our hub site. So I'll pass it back to you, Jenny.
Thanks, Erin.
Let me just stop sharing here, sorry.
Okay, so through the hub, we're aiming to tell the story of the Arctic and Arctic change from many different perspectives, including those from individuals and groups outside of the science community. And Erin and I wanted to quickly share our recent experience working with policy students through the Arctic Data Stories workshop this past winter. And this was co-hosted by Woodwell Climate and Harvard in partnership with Esri. And we found that story maps are really this powerful way of sharing information in a way that is visually appealing, very interesting, but also allows us to bring in a lot of geospatial information in the form of maps and other data visualizations. So our objective here was to expose Harvard policy students and policy students from elsewhere, including Tufts and the London School of Economics and Policy. And then policy practitioners, we had students from the World Resources Institute, Nielsen's Market Consulting, and the New Center, to the world of geographic information, while also learning about geographic information systems, climate change, and the Arctic. So because of COVID, we offered the workshop in a virtual format, and we had 18 students and many volunteer instructors from Woodwell, Harvard, Esri, and other institutions. For this workshop, we met online for 2 hours per week for about a month. And students had the intensive crash courses in ArcGIS using Esri Learn modules. They learned about data visualization and cartography. And importantly, they learned all about Arctic climate change. For final projects, we had the students form teams to design and publish their own story maps. And each of the story maps are detailing an aspect of Arctic change that were self-identified by the students. And I want to emphasize how remarkable it was what the students learned and accomplished in just over a month, especially considering that most of these students had no prior exposure to GIS and making maps. And we really couldn't have accomplished this without our very talented and passionate volunteer instructors, and without help from Esri's Learn ArcGIS modules, including this one, which showed students how to get started with the story maps. And it really helped our team too, because a lot of us hadn't worked with story maps before. So the online tools that have been developed by Esri, they really were so user-friendly. We were able to come in as a group and leave feeling this accomplishment. We were able to produce something, and we learned a lot in the process. So it was a great experience working with these online modules. And you can find the resulting story maps from the workshop within the Stories tab at unstableground.org. Aaron showed some of the locations of these stories. And I want to highlight a couple of these because it really shows the importance and the power of using story maps to share information and to tell the story of Arctic change, and to convey it to audiences outside the science community. So this first one was developed by a group who were really interested in studying adaptation in the urban Arctic settings. So if you recall, one of the maps we showed earlier shows the locations of cities within the Arctic. And so a lot of people are housed within these areas that are experiencing extreme changes and a lot of risk to infrastructure resulting from global warming. And so this particular story map highlights some of the ways these Arctic communities are adapting to risk to protect them from environmental, economic, and social challenges. So I think Aaron's going to include a link to this story map in the chat, and I invite you to check it out. And it's really an interesting story map and so relevant. Another story map from the workshop focuses closer to home in the Boston area. And in this story, Caroline highlights the dangers of Arctic warming and ice melt and projections of coastal flooding, which are threatening the Northeast. And she developed this story map with her family, which really makes it even more special. And she wanted to share this message for her daughter, who's shown here in the picture. And she's thinking about the next generations in the Boston area and in the Northeast and the dangers they're going to face because of rapid ice melt and coastal flooding. And again, I invite you to check this out. Erin will post a link to this in the chat. If you scroll to the very end, what I also think is really important about this particular story map is the inspirational messaging. So a lot of times we tell the story of the dangers of the Arctic and climate change. And this story map takes it a step further, because at the end, Carolyn is telling children and families what steps they can take locally in their own neighborhoods to combat climate change and to raise awareness. So this is a great way to share information and to empower families and students to get out and make change happen. So in closing, we know that what happens in the Arctic does not stay in the Arctic. The Arctic is changing rapidly, and this is really bad news for the planet. We at Woodwell, along with our colleagues at Harvard, Esri, and elsewhere, are on a mission to sound the alarm by sharing data, stories, and this is aided by the intersection of Esri software, science, and community knowledge. So with that, Erin and we thank you for hosting us today, and we are happy to answer questions.
Now you can see why I was so blown away. Just amazing, amazing work. Thank you so much.
Absolutely, yes. And just a reminder to folks, you can post your questions or comments in the chat within this event on Whova. And it does look like we have one question here that, Erin, I think this one's directed towards you, maybe. How did you add the trend lines to your dashboard?
I think that was on the app that they're referring to. So that was developed by Bob and John, who are much more skilled at coding than I am. So they would have the secret to that powerful metric.
All right, I imagine too that we might have some sneaky dashboard wizards in our NEARC community. So if anybody has the answer to that question, feel free to put that in the chat too.
I guess,
curious.
sorry.
Go ahead.
Can I just add one thing? So I know that we had kind of different data sets. So there was kind of the annual data sets that was used to populate the map. And then we had a different data set for the trend. So the trend was used a different data set that had already calculated the trend analysis. Yeah, that's basically the last little tip that I can offer.
Thank you. Yeah, one observation that I had on a lot of the maps that you were showing, Jennifer, is that it looked like Greenland didn't have any data on it. Can you explain why that might be? And even things like when you were showing temperatures or pretty much all the maps you showed, it looked like Greenland didn't have any data.
That is because, great observation, by the way, you have a really good eye for maps. It is because we're masking out ice sheets. For a lot of our assessments, we're looking at the terrestrial, so the land environment, and we're removing ice. So to deal with ice, especially with satellite information, we really need to bring in other data sets and radar technologies. And for this particular project, we're focusing not on ice, but more on land.
Someone was asking if you could share the link to the dashboard that you shared.
Unfortunately, we're not able to share it at this time. We just have to confirm the server hosting to make sure that it can handle kind of increased traffic. So it's still in its early development phase, but we're in the process of figuring out a host for that. So we should be able to have it up on the hub within the next few months or so. So if you follow along, then you can see when we add it, and yeah.
And I imagine too, they could follow you on Twitter and you would post to Twitter when that gets published?
Yeah, exactly. We're a little bit more active on Twitter. We also have an Instagram, but Twitter would be where we'll release kind of our new content as it comes out.
Great, thank you. And I did put a link to the Twitter in the chat as well.
I have a question for Aaron.
Yeah.
I've seen lots of hub implementations, and yours are among the most elegant and beautiful. And I'm wondering, is that all hub straight out of the box? Did you do any sort of custom programming? Any kind of secrets to how to turn a hub site into such an effective sort of public information and education tool?
Yeah, so it's pretty much just out of the box. We used a lot of spacers to kind of get that center panel, and actually a lot of spacers in general just to have kind of the margin. So that white space really allows people to focus on the content we want to draw their eye to, rather than having information in color kind of all over the page. The only custom thing that I developed was the footer, which I'm proud of, but I wouldn't say it's anything exceptional. So yeah, it's just using the drag and drop layout. So yeah, very accessible.
Great.
And Alan, it wasn't this beautiful a few months back. So this has been a work in progress, and Aaron has been really the driving force behind it, but we've gone through a lot of beta testing, and we brought in other people to get outside feedback about what visually is appealing and what is not. And a lot of little things, just like changing text size and placement and the layout, really transformed the hub to what it is today.
Yeah, hub is very powerful, but it can be a little busy and cluttered, especially for general audiences. So you've been very wise to kind of open things up and use those spacers to keep things kind of simple and accessible.
And to the audience, we welcome your feedback. So if you go on the hub, there's an opportunity for you to scroll through and then provide what you think. So there's a user interface, and we welcome your comments and suggestions.
Yeah, in the footer we have a feedback page, and that has the survey 123 embedded. So we've been able to collect some feedback for people who are eager to provide it. And yeah, we would love to hear from you.
We do have another question here, and it says, would an increase in vegetation be a negative indicator in some instances? For example, increased growing season or invasive species?
We generally like to see more vegetation, just because the vegetation through photosynthesis brings in more CO2, so you have more sequestration. Of course, the Arctic is complicated and there's a lot of feedbacks, but a lot of times when we do see insect outbreaks, we see a decrease in vegetation. So it tends to be the opposite.
I was kind of curious along those lines. Aaron, you mentioned that after there's a burn or a fire in an area, that the albedo in that location can actually increase due to that dark burn area. And I'm wondering if, does that mean that fire is particularly bad for the Arctic, or can you explain a little bit more about the albedo and the effect that fire might have in potentially warming the area?
Yeah, so the fires have definitely been increasing with climate change, just the warmer and drier climate that we're seeing, which is really conducive to fires. And in the Arctic, so I kind of mentioned that the ground can actually burn because there's so much organic matter stored in the ground. So you can actually have what are called kind of these zombie fires, where they last over winter and then they can show back up in the spring, which is pretty wild. So as far as the albedo, I mean, there are a lot of albedo feedbacks in the Arctic, you know, from melting sea ice, you're losing that reflective surface. And so for the wildfires, when you have the deposition of the black soot, that dark ground will absorb a lot of heat. And as the heat is absorbed into the ground, it really increases the thawing of the permafrost, which can then lead to kind of those slumping effects, the ice can melt and really destabilize the ground there.
Zombie fire sounds terrifying. That's very like Game of Thrones or something. Alan, did you have any other questions or comments?
Sorry, just lots of praise. Just a really amazing work. I'm speaking out of I'm sort of this might be a little confidential, but Esri's working with the White House on a climate project, and as I was watching this, I've determined to let my boss Clint Brown know that these hub sites are a perfect example of the kind of thing we can do to tell these important stories both to policymakers and to a broad public. Just great stuff.
And in terms of the public, have you been doing any sort of like outreach or crowdsourcing from some of the natives in these areas to hear about maybe their stories or experiences of how things are changing in their area?
Yeah, so that's something that we're hoping to explore in the next phase of our project. So we do work with Indigenous peoples in Alaska, where we are currently, that site in the Yukon-Kuskokwim Delta. But one issue that we're kind of hesitating about is there can be kind of lower bandwidth in the north. So kind of a logistics issue of not great internet all the time. But we are very interested in kind of sharing their stories, collaborating with the local knowledge holders, because they're the true experts of the land. They're living there, they're witnessing these changes. And we think it's really important that they're able to share their stories, and we want to try to amplify their voices as well. So in our initial phase in this first year, we were just kind of getting the bones of our site, but the community aspect and kind of we're hoping to have sort of story maps from the Indigenous perspective as well. So we have an idea for an app for local residents that might help to assess kind of hazards in the area. So we have a few ideas of ways to, collaborate and co-exchange knowledge. So really excited for where that will take us.
And one of our wish lists is to get these story map workshops out to the villages. Because what a wonderful way to bring together all these generations and be able to share their stories in this format that the world can see online.
Any thought about doing Russian language versions of any of these things, given that Siberia represents a huge chunk of the Arctic?
Yeah,
we've toyed around. Yeah, we've toyed around with the idea of having Russian language classes so we can speak Russian. So we'll have to figure out some translators, and it's not off the table. We'll definitely explore that in the future. So.
And Alan, maybe that's a question for you, and something that I've thought of too, for working on story maps in Cambridge, is there a way for folks to be able to translate some of their story map content to another language?
Oh, well, of course, you can use Google Translate just to get a rough sense, but sometimes the results can be a little hilarious, decreasingly so, just because their algorithms get better and better. But of course, with any story, you can create a duplicate story. As an author, you can create a duplicate story, and then just simply recruit somebody with knowledge of the language to kind of take it on. We've worked with some of our international distributors who've been interested in doing local language versions of stories that we've produced. So I recently did a 30 by 30 story about the push to protect 30% of Earth's surface by 2030, and Esri Colombia did a Spanish language version of it, and that's very exciting to us. So we're working to enhance and increase our international and local language presence, primarily through Esri's network of distributors.
We did have another question come in from the audience. It is, has there been an increase in stream and river size since these studies have started? And has that had any effect on the permafrost?
Yeah, but we actually see in a lot of the Arctic regions, because when the permafrost thaws, and sometimes you have ice on the permafrost and that melts, so we see an increase in discharge, so the amount of water flowing from Arctic rivers. And as far as the actual size changing, it really depends locally on channel flow and a lot of other factors, ice dams, that can happen. But overall, across the Arctic, because of the loss of water coming out of from these thawing permafrost soils and rapidly melting ice, we are seeing increase in discharge.
Have you noticed too that with some of, I'm thinking about the wildlife in this area. I mean, you had that slide that was showing some of the native animals and species that may be impacted negatively by this, but has there been any notice or trends in wildlife or different species that are thriving or populations that are increasing due to these changes?
Yeah, rodents. They're resilient rodents. It's, climate change is really difficult on large mammals because it's more difficult for them. They have migration patterns, and it really, when the ground is less stable, so unstable ground, and it's more boggy, it's really difficult to travel. If you've gone out to a wetland and tried to walk across a landscape, you've experienced this. You start sinking in and it's really unpleasant. And then you throw into the mix, in the Arctic, we have a lot of mosquitoes. So if you're not able to move rapidly across the landscape in the summer, you are prey to all those mosquitoes, the hordes and hordes of mosquitoes. So it's the little animals who I think are doing better as opposed to the large mammals that we know and love.
Yeah, I would maybe just add on an even smaller scale, the microorganisms are really able to thrive in the warmer temperatures, and with this organic matter that's being liberated, they can really just kind of feast upon this new buffet that is thawing before them.
Yeah, but certainly, as you said, those large mammals in the area, those are the ones that it's really important to be able to protect them. And so anything that can be done for that is incredibly important. All right, well, I'm not seeing any other questions coming in. So I just want to say thank you again so much, Erin and Jennifer, for sharing this interesting and important topic with us. And thank you again, Alan, for joining and giving us a little story map background. This has been a real treat for our community. And yeah, thank you again so much.
Thank you. It's such a pleasure.
And our collaborators.
Thank you so much.
All right, great. Well, thanks so much for joining, everyone. We'll have a little bit of a longer break now, and the sessions will start up again at 10:30. So thank you, everyone. We'll see you soon.